Hi everyone, Mr. Markwick here. Today's video, I'm going to go through the solutions for question 2 from the 2024 SACE Stage 2 General Mathematics exam. It's a question on statistics and more specifically, the normal distribution curve. So let's jump straight in and start reading the question. The age at which Australian children start walking is used as a marker for childhood development. The data collected is normally distributed with a mean of 14 months and a standard deviation of 1.75 months. Question A says to calculate the proportion of children that start walking between the ages of 10.5 months and 14 months. Now notice that obviously 14 is the same as the mean, and you'll notice probably as well that 10.5 is actually exactly 2 standard deviation steps below the mean. So we can use the graph if you want, but I'm going to show you how to do that using the graphics calculator, or work out that answer using the graphics calculator anyway. Okay, head into obviously the stats function there, and we are looking at distribution, so F5, normal distribution, so F1, and normal cumulative distribution, so F2. Here we are putting in some variables rather than using data from a list, so press F2 for variables, and then we can go ahead and set our lower and upper boundaries. Our lower boundary will be 10.5 months, our upper boundary will be 14 months. So put those values in. The standard deviation is obviously 1.75, taken straight from the information we got given at the start of the question, and the mean there is 14. So toggle down, and you should be able to calculate that value. I like to see it visually, so I always click on draw, and it gives you the answer here as well. So yeah, the proportion of children that start walking between the ages of 10.5 and 14 months is 0.477 or 47.7%. Either of those values would be accepted. You can actually have 47.7% if you wanted. All right, it's only worth 1 mark, so you don't really need to show these values here, as long as you get that 0.477 value. Or if I think you use the graph, you might get something like 0.475, which is also accepted. All right, moving on to the next part of the question. It says, federal government health guidelines recommend that state governments offer funding assistance if a child is not walking by the age of 17 months. Calculate the percentage of children that may require funding assistance with walking. So here we basically want to work out what percentage or what proportion of children start walking at 17 months or older. Okay, so here our lower boundary is going to be 17, and we're going to set our upper boundary as high as possible. There's a few ways of doing it. I always do 1 times 10 to the power of 99. Again, the normal distribution is going to be, the standard deviation is going to be 1.75, and the mean is going to be 14 months. So just exit out of here and change some of those values. Okay, in particular, the lower and upper. So lower is now 17. Upper is now, 1 times 10 to the power of 99. And toggle down. And again, we'll draw that. And here, the proportion is, let's write that down again. So the proportion of children start walking greater than 17 months or greater than or equal to 17 months is 0.0432. All that works out to approximately 4.32% of children that start walking at 17 months or later. And they're saying that 4.32% of children are expected or may require some funding assistance with walking. Okay. Next part of the question. In South Australia, 19,502 births were registered in 2022. How many of these children are expected to require funding assistance with walking? So here, all we're doing is we're taking that number, 19,502, and multiplying it by this percentage, okay? But obviously we convert that to a decimal before we multiply it, so it goes back to 0.0432. Now, I've already done this one on the calculator, and it works out to be 842.48. But because we're talking about number of children, we're talking about the number of people, so we need an integer value here. We need a whole number essentially. So 842 to the nearest number will most likely need funding assistance with their walking. You could also round that up as well. Obviously, you might think, oh, it's more than 842. 843 would also be an acceptable solution in the exam. Okay, moving on. It says the state government health authority provides funding assistance to the oldest 10% of children not yet walking. Calculate the minimum age that a child would need to be in order to get this state government funding assistance. Okay. So here we're going to use the inverse of normal distribution, okay, because we've got basically an area, a 10% area. We're trying to work out that quantile value, okay? So if you bear with me, we'll just head on to our graphics calculator. We're going to head back out of this normal cumulative distribution here, normal CD, and we're going to head back into distribution, normal, but we're looking at the inverse of normal here, okay? Now, the tail we're going to set here is well, you can do it multiple ways, but this is the way I would do it. We set that tail as a right tail, okay, because we're looking at the higher end. The area is going to be 10% or 0.1. And again, the standard deviation will also be 1.75, and the mean, will be 14 months again. So let's go ahead and put those values in. Right tail, 0.1. The standard deviation and mean are already set. So again, toggle down and ask it to calculate that for us, which works out to be 16.24. So the value of K there is 16.24 months, which you can see is less than the 17 months that the federal government health guidelines recommends. Okay, so the state government actually provides funding a little bit earlier than the federal government actually recommends, which actually takes us on to the next question here. So the next question says, is the state government providing enough funding assistance according to the federal government recommendations? Tick the appropriate box to indicate your answer and justify your answer by making reference to your solutions from part B or part C. So the answer is yes, okay. And, the government or the state government provides funding at, 16.24 months, which is earlier than the required 17 months from the federal government. The other thing you could say there as well is that, the number here, 4.32%, is actually a lot less than the 10% here. So the state government actually provides assistance to 10% of children who are not yet walking, whereas it's only recommended that 4.32% of children will require assistance. So that's another a solution you can provide there if you're referring to part B of your working out. All right, let's keep moving on. It says two other markers for children, for childhood development are the age at which children start to speak and when their first molar tooth eruption occurs. Speaking age is normally distributed with a mean of 17 months and a standard deviation of 3 months. So you can see that because the standard deviation is a bit bigger, the data is going to be a bit more spread. Obviously, the normal distribution curve is going to line up with 17 months. And the second dot point there says the first molar tooth eruption is normally distributed with a mean of 14 months, which is the same as when children are expected to start walking, and a standard deviation of 3 months. So it's got the same spread as the speaking age. The diagram below shows the probability distributions for 2 of the 3 markers for childhood development. It says here, fill in boxes A and B to identify the markers for childhood development shown on the diagram above. A lot of information there. Basically, we've got 3 markers. Okay, when they start walking, when they start speaking, and when that first molar tooth erupts. Okay, so we have to basically match these 3 up with 2 of these curves that we've been given. Now, the first bit of evidence is obviously the middle of that normal distribution curve. So this normal distribution curve here lines up with 14 months. This normal distribution curve here lines up, or has a mean of 17 months. The only thing that has a mean of 17 months is that speaking age, okay? So B is actually the speaking age, or the normal distribution curve for the speaking age. Now, because I know that the molar tooth is also going to line up at 14 in terms of its mean, so molar teeth, in fact, let's use a different color. Molar teeth have a mean of 14 months, but so does walking. All right, so walking has a mean of, so this curve A could either be walking or the molar tooth eruption. However, because this curve isn't as spread as the speaking curve, and the first molar tooth eruption has the same spread as the speaking curve, then A must actually relate to walking. Okay, so the molar tooth eruption curve will be the same height as the speaking one, okay, but also line up with a normal distribution of 14. So it's going to be a little bit lower in terms of height than the walking one. That actually takes us on to the next question, actually. It says, using the information provided throughout this question, draw the missing probability distribution on the diagram above. Now, according to reports, this one was missed by a lot of students because there was no box there for them to fill in. A lot of students just missed this question. So, this should look something similar to what I've drawn here. Okay, I think the important thing is, as long as you're getting the height the same as that speaking height, and you're getting the middle of that curve to line up with 14 months, then you're doing the right thing. So that will be acceptable in the exam, or that curve that I drew would have been acceptable in the exam. Last part of this question then says, the federal government health guidelines recommend that children who are not speaking by the age of 24 months should start receiving funding assistance with speaking. Is a child more likely to require funding assistance with walking or speaking? Support your answer using appropriate calculations and reasoning. Now, I think we kind of worked out that children would require some assistance with walking, or about, we expect walking about 4.32% of children need assistance with walking. So is there more or less children needing assistance with speaking? So let's work that out. Now, we know that with speaking, the standard deviation there was 3, so it was a greater spread. The mean was 17 months, okay? And what we're going to do is going to set the lower boundary here for 24, and try and work out what percentage of students fall, above that. So your upper boundary is obviously going to be, again, 1 times 10 to the power of 99, or as high as possible. So what percentage of children, require help there? So above 24. So what does that equal to? Right, let's have a look. Head back. We're out of the normal cumulative distribution now. We're heading back into, we're out of the inverse of normal. We're heading back into the normal cumulative distribution. Here we're setting our lower boundary to 24, our upper boundary to 1 times 10 to the power of 99. The standard deviation here is 3. The mean is 17. And let's go ahead and toggle down and see what that looks like. And there you can see that, P is now equal here to 9.81. Now this, be careful here because it's got here to the power of -3, also times 10 to the power of -3. That's scientific notation they've given us, so that is a little bit tricky. Be careful with that because that's not accepted in the exam either, so you've got to convert that. That's actually, if I move that decimal place, because it's a -3 places to the left, it becomes 0.00981, which correlates to less than 1%. We're talking about 0.98% of children needing help with speaking, as opposed to 4.32% of children needing help with walking. So you would say, therefore, more children would need help walking. Well, it's more likely, I should say, that children would need assistance or funding for assistance to walk. And that's it. Okay, that's question 2 from the 2024 Stage 2 General Maths exam, and hopefully that helps. Thanks for watching, guys.